Hello, I'm Max Lupul, and my project is Analysis of Quality Indicators of Natural Oil Sorbents. Accidental spills of oil and oil products that occur at oil extraction and refining facilities during the transportation of these products cause significant damage to aquatic ecosystems. Sorption cleaning is one of the most effective methods used to remove oil pollutants. Materials used to collect oil and oil products from the water surface are commonly called oil sorbents. Currently, organic and organic mineral sorbents are becoming more widely used. Their main advantages are environmental friendliness, a wide raw material base, high hydrophobicity, and oil capacity at relative cost. The goal of this work is to determine the effectiveness of the use of oil sorbents of natural origin by analyzing their quality indicators. To achieve the goal, the following tasks were set: to investigate oil and water absorption capacity of sorbents of natural origin, perlite, sawdust, activated carbon, and biosorbent econidin; to study oil capacity of these sorbents when removing oil from the water surface; to determine physical and mechanical parameters of studied sorbents, bulk density and buoyancy; to calculate economic efficiency of using studied sorbents of natural origin in cleaning oil pollution. Study of quality indicators of sorbents was carried out in the laboratory under static conditions at temperature of 18 degrees Celsius. The experiment used Ural's oil mixture. Perlite, sawdust, activated carbon, and biosorbent econidin were taken as the sorbents. To assess quality of oil sorbents, the following indicators were selected: oil and water capacity, sorption capacity of oil from the water surface, buoyancy, and bulk density. Oil capacity was determined as ratio of mass of oil absorbed by a sorbent to the mass of dry sorbent. Water capacity was determined in the same way, while bulk density was determined as a ratio of the mass of a sorbent to the volume it occupied, buoyancy by the amount of sorbent that remains on the surface of water after a certain time. At the first stage, the absorption properties of sorption materials were investigated, depending on the contact time. As can be seen in the figure, perlite and sawdust have a higher water capacity than oil capacity. Regarding econidin and coal, we observe the opposite picture. These sorbents have higher oil absorption capacity than water absorption. In addition, the oil capacity of the studied sorbents varies depending on the contact time with oil, which is associated with structure of sorbents, in particular their porosity and saturation time. According to the results of the research, a high oil capacity of wood sawdust and perlite, which was 5.39 and 5.14 grams per gram respectively, was found compared to econidin 2.47 and coal 3.86 grams of oil per grams of sorbent respectively. At the same time, perlite and sawdust have high water absorption capacity compared to econidin and coal. Therefore, according to this indicator, the use of econidin and coal is more rational, or is necessary to hydrophobic dust and perlite, which will also allow them to be used more efficiently. The next stage of the research is study of oil sorption by sorbents from water surface. According to the results of the research, it was found that the share of oil retained by perlite and sawdust is 42 and 44%. Econidin and coal retain 62 and 63% of oil respectively. The quality indicators of oil sorbents include buoyancy and bulk density. High buoyancy allows sorbent to stay on the surface for longer time without causing secondary pollution. It was found that sawdust and coal have lower buoyancy of 78 and 82%. Perlite has a buoyancy of 99%, which can be explained by its structure, while econidin's buoyancy is 91%, since the carrier in this biosorbent is sphagnum moss, which has high buoyancy itself. Bulk density is main indicator of efficiency when choosing the sorbent. This indicator is related to transportation and economic profitability of using the sorbent. In order of increasing bulk density, the studied sorbents can be placed in the following order: sawdust, perlite, coal, econidine. The cost of studied oil sorbents was researched. It shows that it is economically advantageous to use econidine and wood sawdust for cleaning oil pollutions. These materials have lower cost than activated carbon and perlite. Therefore, analysis of the quality indicators of studied sorbents of natural origin showed that taking into account the main indicators, oil capacity, water capacity, sorption of oil from the water surface, buoyancy, bulk density, and cost, it's more effective to use the biosorbent econidine, activated carbon, and perlite. To use wood sawdust as oil sorbent, it's necessary to first hydrophobize it. Also, given the high oil capacity and low cost of wood sawdust, further research is necessary to optimize the use of this material as oil sorbent. Let me not dwell on the conclusions, as they were made during the report and presented on the slide. Thank you for your attention.